Today we are going to study some mechanical properties of metal. Now, when matter, whether it is liquid, fluid, solid, when they are subjected to mechanical force, there is a deformation in the shape. Now, depending upon the type of matter and the shape of matter, various type of strains and stresses are developed in the body, which is what we are going to look at today. First term we come across is longitudinal strain. This normally happens if the body is relatively longer compared to other dimensions like wire, rope, or rod, etc. Now, when you apply force here, suppose we clamp it here, then if the original length was L, due to application of force, the length gets extended by small portion delta L. Now, what is longitudinal strain? Longitudinal strain is basically change in length divided by the original length on application of force. And how do we define that? We define longitudinal stress as force applied upon area. Suppose we take the case of this wire or rope or rod. This is the area we are talking about, because when we apply force, this force is applied over the whole area. So longitudinal stress is defined by this. Longitudinal strain is defined by this. And we define a term called Young's modulus, which is nothing but longitudinal stress over longitudinal strain. So it becomes, what was our stress? Stress was our 4 by A, F by A, and strain was change in length divided by the original length. This is our Young's modulus. This longitudinal stress or strain we also define as tensile stress is tensile strain. We can use these two terms interchangeably. Now let's take another case wherein we have a body, something like this. Let's call it has corners A, B, C, D. What we do is we apply force into opposite direction across this face. Then what happens is that the body deforms slightly and this point D gets displaced to this and this point displaces to this. So this is our new shape of the body. This force as we applied here is called shear force. So again we define shear strain as change in length. Now the point D from here, it went to point D dash here. So what was the change? Change is E by D dash. And over which length? Over this length. The longer this dA, the longer will be dd dash. So what we define as change in dd dash per unit of dA. Right? And similarly, we define shear modulus as shear stress over stress is what? Whatever force we applied, and we applied over across this area. So this area was A. What was the strain? Strain was d dash over dA. So this is our shear modulus. Right? Now the third type of change in shape is called bulk stress or strain. Let's take a small ball or a balloon and we press it from all sides. What is going to happen? Its volume is going to change. Let's say the new volume becomes this. So what we are doing, we apply force here. Now, since the force is applied over the whole, all the surface, we call volumetric stress as, we have been normally calling it F by A. This is, in this case, it will become pressure. And what will be volumetric strain? It will be change in volume divided by original volume. So we define bulk modulus as B, which is equal to F by A divided by delta V by change in volume by original volume. This is equal to pressure divided by this is our bulk modulus. Hooke's law. What is Hooke's law? Hooke's law says that for small deformations, stress and strain are proportional to each other. Meaning thereby, if we take our case of a long wire, and we pull it by a force, more the force, more will be the extension. And conversely, more the extension in the wire, more is the force required. So they are proportional to stress. Stress and strain are proportional to each other till it comes to the body comes to a breaking point.